UEFI is one of those technologies that the goalkeeper is weak on, so to speak. With this parser, what we're trying to do is really bring in the light to open up, to give the defender the same amount of tools. In many ways, the attacker has the advantage. He can actually punch through many holes to find out which one works, and one he gets through is fine. But for the defender, he needs to understand all the holes, not just one that succeeded.
On December 17, 2025, the SEI's CERT Coordination Center reported a newly identified vulnerability in certain motherboards supported by the Unified Extensible Firmware Interface, or UEFI. The motherboard firmware was vulnerable to early boot direct memory access attacks across architectures that implement UEFI and IOMMU. This is an example of the latest vulnerabilities that have been steadily proliferating in an essential but not well understood part of our software ecosystem. Welcome to the SEI Podcast series. My name is Mike Winter, and I am the Deputy Technical Director for Threat Analysis Division of the SEI's CERT Division. Today I am joined by Vijay Sarvepalli, the Principal Engineer for Vulnerability Analysis with a special focus area on UEFI. We are here today to talk about the CERT UEFI Parser, an open source tool the team has developed that reveals the architecture of UEFI software, a veiled source of vulnerabilities. Welcome, Vijay. How you doing?
Very good, thank you.
Well, thanks for joining us. You have been a guest on the podcast series before to discuss your work in vulnerability research. For members of the audience who have not seen or heard these previous episodes, we will link to those. We will send a link to those in the show's transcript. So, can you tell the audience a little bit about yourself, the path that brought you to the SEI, as well as the best absolute part of your job?
I started working on software somewhere in 1990s, early, just doing development of software for instrumentation. Primarily, that's where my career went off, starting from electrical engineering. I really didn't think of software picking up as fast as it would, but within the next 10 years, software just changed everything. So from 1990s, I've been in this type of industry in one form or another. So it's been a long time I've been in this industry. And what brought me to SEI? Primarily, it was a career time when I'd reached the maximum of contributing to the industry. There's lots of different things I was seeing that had to be addressed, especially cybersecurity. I was looking at it as a long-term thing to look into, and I was running my own company at that time. 80% of my work became more and more securing what was being written by others. So it felt like a really good fit to join SEI. It has been. I've not been able to leave for a long time. So that's been the best part of my job. I've switched many different roles in security, the vulnerability being the latest one. It's all been exciting. There's been so many things that I've both learned and be able to influence industry, SEI itself, and how we think about software, and at large, DoD and the U.S. government, how we go about planning for software for many generations to come.
Oh, that's excellent, Vijay. I think we probably just do a podcast on your career alone, starting electrical engineering all the way through cybersecurity and not being able to leave the job, which is fantastic for us. Good news for America and our national security. So I understand you grew up playing soccer. What position did you play? And, what did it teach you? And, how does it inform who you are today?
Yeah, playing soccer, we started playing soccer on the streets and the beach, kind of no shoes, nothing, but just ball and kids, that's it. That's where we started. So I'd always been like, I had a good eye for the field and I had good speed. Those are the only two things I had. Other people had much better skill, but I loved playing, I just loved being in the field. So most of the time I played attacking mid, but I'll do sometimes like left extreme, which is, they don't use that term anymore. It's a winger nowadays, it's called. So I basically run back and forth very, very fast. And sometimes with the ball. But my whole technique was to basically find other people in the right position and deliver the ball to the dangerous areas, either for defense or attack, depending on what I'm doing.
Great lifelong lessons, especially professionally too. Who's your team?
My favorite team is Manchester City, long before they were famous, honestly. So they can't complain now. Only Holland and De Bruyne and all these names now are made them famous. But I've been their fan before they came. I've been tracking them for a long time. I like the way they play as a team and they play together. And many people come in and out, but the culture has remained in one direction of the team culture.
Yeah.
Build up and what I call ease defense and coordinated attack. It's very easy defense. I mean, they make it look so easy in the defensive part, and the attack is so intense that the defense on the other side is always afraid as to what's going to happen.
That's excellent. Well, perhaps a new goal of this podcast, and that is a terrible pun, and it was intended to be a pun, it will be for De Bruyne or Holland to probably download the parser and use it. So we'll see if we can get them to catch on this one and do that. So.
Yes, De Bruyne, especially as he's retiring, he should be worried about cybersecurity.
So this is where soccer and cybersecurity, come together in this podcast. So well, let's jump on to the pitch and kick off. And so let's begin with an overview of the Unified Extensible Firmware Interface. Thank goodness we call it UEFI. Vijay, you've been tracking UEFI for a number of years, and you're one of the true experts we have. And so when I was thinking about this last night, I was thinking, as this relates maybe to soccer, this is kind of like offsides. It's a vital, part of the sport, but it's incredibly challenging to explain it to somebody. So what is UEFI, and what are its inherent risks?
Yeah, UEFI came as a standard because we are the legacy software we had and hardware interfaces were very, very broken, very limited, and you had no real way to update them. And you're bringing in a lot of plug-in hardware nowadays. Mm-hmm. You're turning on hardware, switching it on and off all the time. Your laptop just sitting there is actually turning on and off all the time. Mm-hmm. If you didn't know about it, it's doing many different things. So these are the things we want to support, where the legacy BIOS, which talked to hardware, had hit its limitations. So Intel early, somewhere around 2000, they started looking into this, and many big brains started focusing on writing a standard that will force everybody to write these type of protocols and interface and help talk to hardware in a standard way. That's finally what it is. Operating system reaching into hardware in a very standardized way is what the standard provides. But this meant like an explosion of possibilities now. It is said the man is anxious once he knows his freedom because he has all the options before him. There's so many options about what you do with UEFI. Yeah. And it started transitioning into many different things. One of the key things that UEFI innovated is getting rid of old CMOS, where you had a firmware that you couldn't update to something you can update, and you can actually sustain many early boot processes that actually made it clear as to what the operating system should do with the hardware. So that was a very, very powerful idea, but it also brought in a number of risks. Once you open up the field, that's what you're doing. You're bringing in a lot of different risks. All these interfaces had to be handled properly, had to be understood, and had to be clearly defined. And that's a big task. That's a very difficult task to do. And UEFI standards had to be upgraded all the time. And without a sample implementation, nobody reads the standard. Nobody reads the base standards anymore. So that implementation took on, and slowly vendors started implementing it. Soon we found out things that are very key to UEFI, more than they expected, was the security aspect, because you are doing very, very early trust relationships that will remain with the operating system all the way through. In fact, we make fun of this, saying it even remains after life, meaning your computer all the time sleeping and waking up again, like we talked about just now, as laptop especially does so many times, this thing. But within that cycle, you're re-interfacing with hardware, asking a lot of questions about where I was, what happened to me. Right. And you could point it to somewhere else than it was to execute code that never knew it even existed. So those are the tricks that people didn't think about as UEFI started evolving. Many risks we are taking on as we started scaling this interface between operating system and hardware.
Okay. So perhaps UEFI is more like Man City's defense. It's supposed to protect, but sometimes it might let a few things through, huh?
Very true. That's a very, very good way of looking at it, because the risk, like I said, when you open up the field, like if you were to talk soccer, when you basically push forward and have your defensive midfielders and backs all the way forward in taking a risk on taking on new challenges, new ways of attaining goal, you're opening up the field in the center, and you need to really start thinking about what are the things that the attacker can do, like early attacks and long shots and things like that you were not prepared for before. So you basically shifted the attack in some ways for the other team. This is what the attackers started picking up. I'll give you a simple example. Sometime in mid 2010, 2015, sometime there was they believe some financially focused hackers who got into financial systems and planned this really deep UEFI malware, and took about 9 months to figure out what it was. It took about 3 more years to try to get rid of it. And 5 years later, it's still not quite gotten rid of it.
Oof.
And the final solution was replace pretty much the hardware. Take the thing out and throw it out. We can't. There's no way to guarantee that we got
brute
rid of
force.
this. So that type of opening that we left for the attacker, so to speak, in this scenario is something enabled by UEFI in one sense. As much as we push forward these really high capabilities of doing very, very fast transaction, giving system tables to operating systems as a virtual map of where the real memory is, that was very powerful. You did not depend on real clock memory to understand how to talk to it. You had this really, really convenient map, and it could really go and grab things from memory very, very fast. But we took on that risk too.
Well, let's stay on this topic of vulnerabilities. I understand that today the number of reported UEFI vulnerabilities has recently gone up, as we mentioned in our introduction. So in the last 2 months, how many UEFI vulnerabilities have been reported to the CERT Coordination Center?
Things that we have not yet gone public are already like 6 or so, and last few months there's been 7, and there's always this counting vulnerability game too here. You're counting vulnerabilities, but each one of these vulnerabilities, take one of them, called a secure boot bypass, literally impacts every machine ever sold in the past year. That's 290 million PC machines. All of them are impacted. All of them need the update. All of them have a difficulty taking the update, confirming the update, and all of them have lots of different ways in which this update can go wrong. Either to break the machine, so you're very afraid to push the update, or make the machine slow or underperforming, that you're unaware what to do. So it's not an easy problem to solve. How do you really, each one, the counting vulnerability is one game, but the counting impact of these vulnerabilities is very different. So that's why we almost coined this term called systemic vulnerability, where we look for deeply embedded flaws, things that are very elusive, very difficult to fix. So in that sense, the counting is tricky. The numbers really don't tell you or give you fair information of how bad the risk is that we're taking by not doing this patch.
So now that I'm not going to sleep for a long time, I'm now curious, why is there an uptick in UEFI vulnerability reporting? What do you think the catalysts are behind it, given that we know the attack surface is so great, like you said, up to almost 300 million, and we're starting to see an uptick now in reporting? What do you think is driving the increase in vulnerability reporting, or maybe the catalyst behind the reporting?
There are probably multiple factors. It's hard to say one thing that contributes to it. I would say any technology that we take on takes some time for us to understand how it gets implemented. There's one standard like book, a Bible like book written that you think is the ideal way to do things. Then there's implementations, and you find out implementations are driven in a particular way, and they take the technology in one direction. So it's taken us some time to figure out where this has gone, which risks we've taken on openly, which risk has inherently been difficult to access, even if we took it on. So that has been part of it. And then the attackers need some deep knowledge to work on this stuff. As we call script kiddies, quickly go after things that are easy to attack. This is not generally for script kiddies. But the time is coming when there's going to be frameworks, just like Metasploit has, for attacking UEFI once that happens. So that's where we are headed slowly. We're basically building this portfolio of attacks which are attacking the whole life cycle of UEFI. The phases through which a computer boots up is where all the risks are, including the phase after its UEFI has disappeared and the operating system is taken over, so to speak. There are still risks that we linger behind. So those are getting exposed as these attacks go up, and the technology footprint is big enough for people to start paying attention to both attackers and defenders.
That makes sense. Well, we're going to put you on the pitch. You're the referee, and you have a red card. And for those of you listeners that don't play soccer, red card, you get to throw somebody off the field with a red card. So if you could red card one UEFI vulnerability permanently out of existence, which one would you red card?
There was one basically that gave rise to what we call the Black Lotus attack. Black Lotus UEFI attack went after a particular software that Microsoft signed and provided as part of their boot process. It was digitally signed by Microsoft, and they had signed many versions of this over the years, and they were widespread. The vulnerability was in the very foundational idea of how we did memory management at the very early stage. I could ramble off the CV number, nobody cared about that. But if you did Black Lotus, as they said, you'll basically come through. There are many proofs of concepts today present. I can take about 60% of our machines, even in our organization, and go through this attack. And likely I'll get through one way or another if I really build a framework around it. So it's a very difficult thing to solve, because if you patch it, you are revoking some of the very critical parts of the early boot system, and how you depended on it over the years had become really bad. So that's a big red card. That's a red card I'd like to give to Secure Boot to really kind of pivot and think about how we sign, how we maintain these signatures, how we revoke them, how we're going to sustain this revocation process too, as things evolve. So that would be the big one. We still find Secure Boot is one of the most difficult things that if attacker finds a way to go after it, it's very, very difficult to resolve it.
That's excellent. Well, I'm all for booking it, if you can, with this theoretical red book here. And staying on the soccer theme, to me, just what I want to hear from you is that UEFI, if it were a soccer position, almost sounds like the goalie. And it sounds like recently we've been giving up a few goals here and there, and there's a potential we could be giving up a lot more goals going forward. So fortunately, people like you are developing incredible tooling right now to give the goalie a better opportunities here. So the CERT UEFI Parser is the tool that you wanted to talk about today. So tell us about the tool and how it works.
So there are many problems, like I said, with the UEFI vulnerabilities that exist. But I think this is a big one for visibility. The Parser tool that we developed is really to start shining a light. It's almost like right next to the goalkeeper, there was an invisible spot for the goalkeeper himself. And we had to start shining a light on it to really tell, hey, goalkeeper, this is something. This is the only corner everybody's been scoring. Why don't you think about it? So UEFI is one of those technologies that the goalkeeper is weak on, so to speak. And we really want to basically enable, with this parser, what we're trying to do is really bring in the light to open up, to give the defender the same amount of tools. In many ways, the attacker has the advantage. He can actually punch through many holes to find out which one works. And one he gets through is fine. But for the defender, he needs to understand all the holes, not just one that succeeded. So that's what the parser does. It really gives him an open map about where UEFI is. We take a binary of an EFI file. You can basically reverse engineer it openly like we do with lots of other software. Clearly find the vulnerabilities, all the related binaries that may have the same vulnerability, how they relate to each other, all the type of questions we can ask today. That's what the parser gives for us. it's really been a little bit backward for us to go back and keep using it.
Yeah.
And we keep finding more and more ways to take advantage of it to address legacy vulnerabilities as well.
Yeah. So on that same topic, so what were some of the contexts and scenarios? Could you give us like a scenario where you would use the UEFI Parser tool, where it can be used?
Yeah, so I'll give a very practical example. Very recently, we came across a vulnerability which had to do with what we call improper use of NVRAM, non-volatile random access memory is the whole term, NVRAM, variable usage. And as it turns out, we found out a particular binary signed by Microsoft, produced by DT Research, Incorporated, was actually part of this. And this particular binary was being used only in very specific laptops that are in a medical situation, and they're very rarely connected to anything outside of the internet. But soon we found out that is not the case. Part of the benefit is from the parser that we started like running through other situations where this particular motive was being used, NVRAM variable, in an improper way. And we found so many other situations where this problem existed. So that's one shining of the light, so to speak, where the parser went beyond seeing the current vulnerability as a single instance to a motive and a mode of vulnerabilities that we want to really address. And how do we really address this, not only by fixing this, putting a CVE out, putting this in the forbidden list of software, but then finding similar problems over the next year to really address all the related vulnerabilities. That's one example.
That's excellent. What are the types of files can the UEFI parser work with?
Yeah, that's the other problem we found when you looked at the parser that existed today. There's so many different file formats, some proprietary, some are inside a normal executable, all different file formats in which EFI meaning this is one of those executable files in the firmware that's UEFI compliant, exist. And we didn't find any parser that does even two of these formats. UEFI tool, UEFI compressor processor, all those things. So UEFI parser brings together all those capabilities into one central spot where we basically can parse executables at the highest level to the very, very small binaries, ELF files, any possible way you talk to firmware will now be exposed. And whatever we don't really understand, we still call it mystery bytes and present it to the user. So they can do their standard reverse engineering or putting it into Ghidra, other tools, and whatever not. It's no longer a confusing thing for them to say, where is this binary and how does it relate to firmware, is something we want to shine a light on. That's the purpose of it's open source parser. It sits in our GitHub repository. Anybody can fork it, give us features. So it's totally written open, and it handles more than 20 variants of binaries. Today, like I said, we hardly found one that would do even two or three together. You have to basically string together tools to do it. So we try to bring this all together. And it's fair to say we also stand on the shoulders of giants. Meaning other people have done this work. We couldn't get here without the other parsers that were written before.
Okay, well, let's take a few more corner kicks on this one. So one thing I just wanted to mention was, as a federally funded research and development center, we are dedicated to serving the public interest with objective, highly specialized, and long-term research and development. Partnerships are certainly our cornerstone, and transitioning our capabilities is absolutely paramount. What I wanted to do is just take a quick second to recognize the sponsors that behind a lot of the work that has been done here. And this really started with some congressional funding that we utilized, and then the Air Force Cyber National Mission Force sponsored us, as well as the Cybersecurity and Infrastructure Security Agency. So we can't do anything without their sponsorship on this parser, so we are eternally grateful. And then you mentioned briefly the location of it. So let's dive a little bit deeper on that one. You wrote in your blog post on the tool, and we'll add a link to the transcript. So where specifically is it located? You said GitHub, but just dig a little bit deeper on where is the UEFI parser tool located, and how can our audience access it after they hear it on this podcast?
Yeah, our GitHub repository for CMU, SCIs, and GitHub.com CMU-SCI is where it is located. We have links for it all over in the blog and everywhere else. That's the easiest way to find it. You can even search for CERT UEFI Parser. We made it available in every possible platform, like pip is a platform that most Python tools use. You can just do a pip install CERT UEFI Parser, and it'll basically pull down and install it and give you some examples of what to run with use cases. So it's very, very easy to install. That's part of our pursuit to make it possible for standard today's developers who understand Python, which is a very popular language. That's where it comes from. We made it compiled and readily available for most platforms like Linux, Mac, and Windows. So if you really do a pip install, you're ready to kick off, already look at a binary, look at one of your ROMs, look at one of the update files that you got from Dell or HP or whoever, which may have an embedded bias in it. This will rip it apart and tell you what is getting updated, why, and what potential CVEs are getting addressed. All that you can walk through and find out what risk are you basically willing to address right away by doing this update. Could be one way to use it. That's just one way, but there's lots of different ways and forensic ways in which you can go after a particular attack that's already done. You can go back and see where once you get this installed in a forensic laptop, you can easily use it to find out how you basically an attacker could have subverted some of your defenses. So that's another powerful way to use it.
If somebody were to download the tool today and they wanted to provide feedback on the spot, because we all want to make this better, how would they provide feedback on the tool?
Yeah, we use GitHub issues for that, very standard. It's open for everybody to basically give feedback. We want public to contribute. Lots of public already contributed. Some of the commercial companies have come in and given us advice about it. And they've written their own extension and given it to us. We included that openly. So it's an open source tool. All the licensing, everything is laid out in our GitHub. And the way to do is standard what we call GitHub pull requests and issues. And if you have both, that's even better. You can give an issue. Excellent. If you have a solution for it, you can put it in a pull request. We're happy to include it. We're happy to extend it whatever way we can. We recently had a very good issue reported by one of the Lawrence Livermore National Lab people who found an issue. We resolved it, and that is one example of how the workflow could be. We'd love feedback like that to try to resolve these issues. Finally, we want to give you tools to bring transparency and openness to this platform. It's been hidden. It's been elusive for many people to understand what it is. That's the barrier we're trying to break. So whatever way we can do that for you, we welcome it.
Excellent. Well, the non-existent chat I have in front of me is blowing up with questions. So I'm going to grab two random ones from this non-existent chat and ask you them. The first one is, if I'm a CISO or a CTO, what should I be doing to ensure my organization remains secure from UEFI vulnerability attacks?
Yeah, this is a big challenge. We bring it up all the time in in our blogs and everywhere. So we have written long-term big recommendations, 5 big recommendations for UEFI, for the whole UEFI industry, which involves what you call IBVs, independent bias vendors, IFVs, the firmware vendors, all of them to pursue. So that's a very long-term thing. Our ways of writing those things are like 20, 30 years ahead. So some people don't really like seeing that far ahead because technology changes so much. But we want it to be a good document at 20 years from now. If people can pick it up and say, oh, yes, that's why we did these things. It's clear. So that's the long-term thing. For the CISO and the defensive posture we have, today, endpoint tools give you no visibility into this. There's no way to use an EDR or even Microsoft Defender and some very powerful tools today have no visibility into the UEFI portion. So we're really pushing that question out. We want them to ask the vendors to give more visibility into UEFI, what types of things are changing in UEFI as things go on, how UEFI is being used post the operating system and before the operating system comes out, clear logging for UEFI, all those things we are pushing forward to try to help bring visibility. Basically, we want the defenders to have clear idea of what is going on. They shouldn't be kind of taken unexpected side tackle, so to speak. Of where the ball is out of their feet without them even noticing this guy was running twice as fast as you. And we want to give them more control, more visibility of those attackers who will be coming after you.
Well, one more fun question as we wrap up. Who needs a better defensive strategy right now? Manchester City's backline or the UEFI security community?
Well, if we can give both of them, I would give them both of them, but in a similar situation. In some ways, they have similar problems. They have a powerful idea in going forward. We're talking primarily about the parsers. I won't talk too much about this, but I wanted the UEFI path forward to be also laid out, which is a little less to do with the parser alone. We introduced close to 18 million machines just in the past 2 months, primarily to serve AI functions today. All the ChatGPTs, cloud, and co-pilots, all of them are introducing new PCs. 99% of them use UEFI for boot. None of them actually use any other system today in a transparent way. The only way to do it is proprietary booting system. Some of them are being explored by Google, like Core Boot and others. Those are very difficult because you have hardware compatibility and other stuff to be concerned about. So thinking about it in that way forward method, we really need to harden this system as we move forward. This is a critical technology and it's going to keep growing only. It's not going to reduce. AI and others are bringing in very, very fast hardware. If you take any of these GPUs, you think you're talking directly to the GPU. The operating system controls all of it. And operating system depends on a boot trust that you depend on. And today you're turning on and turning off thousands of machines, containers all over the place. All of them have this back end that you just cannot ignore. So I'd say that's a very important thing to look into, important way to look forward. And this transparency that we're trying to bring with Parser, to come back to this main topic, is really going to help us bring clarity to the defenders, to all the bias vendors, to really be open and to start addressing them kind of throughout the life cycle, from creation to the release of software. How do they sustain these good software methods?
Well, luckily for us, the referee just added a few minutes of extra time so we can hear some professional words of wisdom from you. And for our listeners that are out there, Vijay is an esteemed member of our highest technical staff. So he's basically the cybersecurity equivalent of De Bruyne and Haaland combined. So we're very, very fortunate to have him here today. So I thought it'd be very appropriate to just ask you a few professional development questions for us to just learn from you over your time here at the SEI and then as a business owner originally. So I just have 3 wrap-up questions for you. The first one, what is a professional area in your career that you are most proud of and why? I.e., what is probably the best goal you ever scored or defended in your career? But I'm guessing it's more of a goal you scored.
I've really liked the idea that best defense is a good offense as well. If I didn't score goals, I wouldn't know how to basically defend and also attack. So that's been my learning lesson in my career. I think the professional area, what I learned from this, especially let me just stay in UEFI for now. There's some big career way forwards, milestones I've faced in my career that's been good. The latest one is obviously this one. It's been a big one because I've been able to understand both defending it and attacking it and coming to this almost like the purple team idea of somebody who understands both and be able to advise and go after technologies where we can move forward. So in that sense, UEFI has been a big winner. I've had challenges with it. I've had my own, what I call own goals that I could have avoided in the way we handled it. But I think overall, this is one area we will leave a mark for a long time. Like I said, we really think 20 years from now, UEFI Forum and others who basically cite would basically be able to pick up this document and say, that really gave us the way forward. And that's been a good investment of our resources, And again, all of that also depends on other players in this game. I really recognize Corey, who's recently going to be retiring, who's contributed a lot on the parser, specifically in writing the parser, who really brought this transparency so I can do the attack and defend and be this attacking midfielder that I've always dreamed of, who scores enough goals to know how to do it, but also knows how to make others score. That way they're not dependent on me. When I'm drawing players away, like Kevin De Bruyne is drawing 3 defenders away, his idea is not to show off. His idea is to release one of the attackers so nobody's defending him. You can give the ball to him. So Haaland gets all the glory. It's okay. It's good, but that's part of the career path that I see myself looking at, how I can basically release up and place these young coming people into this right position, so to speak, to be able to score, to be able to both defend and score, and be able to sustain a career in which they make long-term impacts.
That's excellent. And you mentioned own goals, so we probably have a lot of young listeners, and I know sometimes when I was growing up, I learned a lot from the mistakes people made and the way that they, helped me not make the same mistakes. What would be a professional own goal that you're willing to share with us that, really helped you grow and you learned from?
I think the real own goal I can think of that's been a good and bad in some ways is really our approach to UEFI vulnerabilities themselves. We wrote about them and then we defended them, but it came in a time when technology was too much noise, and many, just like social media, there's so much going on that many of them saw us as prophets and not engineers, and they ignored us, and it took us some time to defend what we said. So I think building that body of knowledge and releasing it first. So we basically are building, I think that's something I'd encourage all the other people who are building up, because there's so much noise in the area. I'd start with very practical, clear examples of what it is that we're saying before we release a bigger document or bigger release of attack chains and things like that. Because it's very confusing for people to say big terms and big ideas without defending them with all these milestones that takes us there, and why we say the big idea exists and all these milestones are important. So I think that's been one thing. I just remember when I wrote that big blog or file recommendation, my phone was off the hook from every vendor, upset about it. Part of the thing, I felt like it is a sort of an own goal, because it can basically confuse them about what to do, because we're asking them to do these big things without telling them what are the small things that take you there. And I think that's something I could have avoided. I would recommend everybody writing on all these things, both for SCI. Basically, if you're writing these big documents, which is okay, start with the smaller ones that are actually in parallel defending it. That's going to be critical, because they're not interested in profits. They're interested in engineers who give them real direction and help them move forward, instead of telling this great thing is going to happen. Thank you for nothing is what what the vendors are going to say. So we really want to elevate the defense of this, and we want to elevate it as it's growing, not in any kind of like negative way or a confusing way, in which the solution is just too big that people cannot foresee a way to get there.
Well, if this is the last question here. I'm sure there's some listeners out there today that this podcast might be on 2x speed, or you're multitasking, you're driving, or whatever. So the final question to you, Vijay, is if you want what is the one thing you would like our listeners to remember from this podcast? If there was one thing we need them to take away.
Yeah, I would say this idea of bringing transparency into this elusive vulnerabilities we face, elusive attacks that happen, is going to be very critical for the coming generation. We are scaling up software very, very fast. The visibility that we need to maintain to understand it sufficiently that you know how to defend it is going to be critical. And CERT UEFI Parser is one of those in that motive of bringing transparency, so the defenders and the forensic people know exactly how to explain what happened, how to be clear about it, and how to really also give you ways to move forward from where they saw the defense fall apart, so to speak, or defense give away goals that they could have easily avoided by being by being aware of the things that risks they're taking. That transparency comes from tools like the UEFI Parser, and people should pursue such technologies, and they should close these gaps in a very consistent, systematic way instead of panicking way where they're solving one or two, like we call whack-a-mole methods of solving vulnerabilities.
Well, and I'll only add to that we also look forward to Manchester City's feedback on the UEFI Parser tool. That's probably the other key takeaway, so look forward to that one. Yeah. So Vijay, it has been my privilege to serve with you, to work with you, to learn from you, to everything with you. You're just such an exceptional human being, and it was my privilege today to get the chance to interview you. So thank you for that. And to all of our listeners, thanks for joining us today. We will include links in our transcript to all the resources mentioned in this podcast by Vijay. And the SEI Podcast series is available in all the places you can find podcasts: Apple Podcasts, SoundCloud, Spotify, and the SEI's YouTube channel. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thanks for listening.